Now in the previous video we had this parcel which had been weighed and the mass displayed as 113.8 grams. Now the machine or the scales that we put it on rounded to 1 decimal place. Let's imagine that we're putting it on another set of scales which doesn't round to 1 decimal place, it truncates to 1 decimal place. Use inequalities to write down the error interval due to truncation. Now how is this different? Well, what you need to do is you need to think about what weights could the actual parcel's mass be. Okay, so if it's 113.8 grams, the least that we had in the previous video when we're rounding to 1 decimal place was this, 113.75 grams. Now if you were truncating this to 1 decimal place, what that does is it removes anything to the right of that first decimal place. And so the display would actually be 113.7. So this can't be the least value of the parcel's weight. So we have to have an 8 here in order for us to truncate and remove everything to the right. So the lowest value, or the least value that it could be, is 113.8 or 113.80, because anything less would have a smaller value here. So 113.7 something or 113.6 something, okay, they would truncate away and you would have 113.7 grams or 113.6 grams displayed on the scales. So 113.8 is the least it could be. Now what is the largest it could be? Well, it could be 113.82, 113.83, 85, 87, 113.89. Okay, so 113.89 would truncate to 113.8. If it was 999, all of that would go. It would truncate to 113.8. Okay, so I can't actually write down the largest value it could be because I could just keep on adding 9s there. So it has to be a value less than 113.9. So in the previous video we had 113.75 and 113.85. The distance between those two was 0.1, and it's the same here. It's the same distance. It's 0.1 away from each other, but because it's truncation, you're looking at a different error interval to when you're rounding.